Okay, I'm going to solve practice exam number 2, part 1, question 7, and then I'm going to do question 9. These are especially tricky questions, I think. Okay, so how do we do this? Looking at this fraction here that we're trying to graph. It's one of these 4 graphs, A, B, C, D. There's no E. There's none of the above, so we know it's one of those 4. How do we do it? Well, first off, remember, whatever makes the top equal to 0, those are zeros on the graph, meaning places the graph hits at a height of 0. Whatever makes the denominator 0, those are vertical asymptotes. Let's start with the denominator. So whatever makes the denominator 0 is a vertical asymptote. So that would be x squared minus 3 is 0. Bump the 3 over. X squared is 3. Then how do we solve that? We put a square root, and when you put a roof on the house, up and down the ladder. When you put a root on both sides, I call it a roof on the house. You got to go up and down, plus and minus the ladder. So you get x is plus or minus root 3. If you do that in your calculator, root 3 is about 1.7, on and on it goes. So that means there should be vertical asymptotes at x is plus or minus 1.7 because that's what makes the denominator 0. Remember, whatever makes the bottom of a fraction 0, that's undefined. That's not, it's not allowed in the domain, and it's a vertical asymptote. So which of these graphs have vertical asymptotes, 2 of them, at positive and negative 1.7? Well, not A. A's out because here's his vertical. This is 2. And so this vertical is past 2. It looks like it's at 3. No way. B doesn't even have any vertical asymptotes. C and D have the right to vertical asymptotes. See how they're not showing them. They don't have to show verticals. But you can tell it looks like there's a vertical right there just before 2. Right, this is 2, so this is 2. So this is just before 2, which, 1.7, that's right. There's another vertical, it looks like at negative 2. Just before that, so negative 1.7. So that looks right. Same thing for D. Vertical here. You can tell there's a vertical there because I can tell because the graph is hugging it. See how the graph's getting really close to it here and here? There must be a vertical here and here. There must be verticals there. So C and D are still in the running. It's either C or it's D. Those are the only 2 graphs that have the right vertical asymptotes. Okay. Next. How about horizontal asymptotes? Remember how we figure out horizontal? Let me change the color here. Remember how we figure out horizontal? We're going to do this whole problem by just horizontal and vertical asymptotes. How do you figure out horizontal asymptotes? It's the numerator power and the denominator. What's the numerator? What's the denominator? It's a x squared over x squared. It's a 2 power over 2 power. Remember, if the numerator power equals the denominator power, then it's y equals a over b, the coefficient, 1 over 1, or y equals 1, is the horizontal asymptote. That's because x squared over x squared, let me show that more logically, x squared over x squared is all that matters when you go way off to the right forever. That's what a horizontal asymptote is about. When you go way off to the right, plugging in like 10,000, all that's going to matter is the most powerful term top and bottom. X squared over x squared is all that matters. That's 1. Y equals 1. So which one of these, C or D, has a horizontal asymptote y equals 1? D does. See the horizontal right here? At y equals 1. C has it at y equals negative 1. Nope. The answer is D on number 7. So we did that whole problem by just vertical asymptotes and horizontal asymptotes. That's how we do number 7. Okay, let's talk about number 9 now. Okay, here's number 9. How are we going to do this one? Well, same kind of issue. We have vertical asymptote. This is at negative 1, and this looks like here's 0 right here. Is that 4? So at negative 1 and 4, there's vertical. So vertical asymptotes at x is negative 1 and x is 4. So that means, where do vertical asymptotes go in the equation? Denominator. So that must mean we have x plus 1 and x minus 4 in the denominator. Because that would solve to be x is negative 1 and that would solve to be x is positive 4. in the denominator, making vertical asymptotes. So this one's out, right? Because he doesn't have x plus 1 and x minus 4 in the denominator. A, B, and D are still in the running. So far, so good. So how do we figure out which of those is really right? Well, the next thing we do is we have to look at the numerator. Look at the top of the fraction, and that's going to be 0. See right here how the graph hit 0 at 3 and right here at 6. So that means x minus 3. Wait, is that there? Oh, no, sorry, that's 2, isn't it? That's x, that's 2. And so 2x minus 2. And x minus 6 must be in the numerator, because whatever makes the top 0, those are zeros. What makes the bottom 0, those are vertical asymptotes, aren't they? Well, that didn't do much for me. They all have x minus 2. A, B, and D all have x minus 2 and x minus 6 in the numerator as well. Well, how about the powers? See how they have, this has a 2 power, this has a 1 power, this has a 2 power, 1 power, 1 power, 2 power. They have some different powers. How do you know what the powers are? Well, this point is a bounce. What does it mean when the graph bounces? That's even power. Remember, like x squared, even power bounces. And this is a pass-through, which means it's odd power. Remember, odd powers like x cubed pass through. So that means at 2, it's an even power. So which one of those has got even power at 2? So it's got to be a 2 power on the 2 and like a 1 or some other odd number on the 6, because the 6 is odd and the even is going to be what's happening at 2 because it bounces there. So which one has a 2 power and a 1? A looks good, B looks good, they're still in the running. Bye-bye D. D's out because he has an odd power on the x minus 2 and an even power on the x minus 6. He has those reversed. He's out. So now, it's all the way down to A and B. How are we going to determine which one it is, A or B? The only difference between A and B is this 2 in the front. Everything else is the same. So how do you know whether it has a 2 in the front or not? I would just plug in a point. I would just do that. I'm just going to make an XY table real quick. I'm going to put in 0. When x is 0, see the dot right here? This looks like it's over 0 down maybe 1.5 or something. I'm just looking at a dot that's obvious and easy to grab a hold of on the graph. That looks like that's over 0 down 1.5. So if I plug in 0 to this function, am I going to get y equals negative 1.5, or will that come out of the b? It's either A or B now. So plug it in to A. So I'm going to plug into x minus 2, putting down A here. So and x is going to be 0. So I'm going to plug in 0 minus 2 squared, 0 minus 6 all over 0 plus 1, and 0 minus 4 squared. What do you get? That's going to be minus 2 squared. It's going to be 4 times negative 6 over 1 times 16. That's negative 24/16, negative 1.5. That's beautiful. A it is. A's the winner. If you plugged it into B, B would have been the same thing, except for B, it would have had a 2 on the top. So it would have been 2 times 4 times minus 6 over 1 times 6. Right? Would have had a 2 right up here on the top. It's the only difference. So that would have come out negative 3, twice as big as negative 1.5. Would have been negative 3. And that's not right. The point over 0 down 3 is here. And that's not the right point. So the graph goes through over 0 down 1.5. So there we go. The answer is A. Hope that helps.